Okay. We're going to look at graphing this without our graphing calculator, but we're just trying to do sketches. So you're going to be able to use the graphing calculator for this next quiz that we're going to do. So this is still part of 2.5. So we're going to talk just a little bit about this multiplicity of a root and what it does to our graph. We will definitely study this more in detail later on. For now, we're just going to kind of note it and see. We're going to do an inequality with it. Okay, so this here, this x minus r to the n, talks about multiplicity. So the n, the exponent, is the multiplicity of that root. It's how many times that root shows up. So first of all, roots are the same as zeros. Okay, those are my zeros of the function. That means those are my x-intercepts. Those are where y is 0. So since this is in factored form, I can use zero product property. And I set each part equal to 0. So I'll say 2x equals 0. So each part that has an x is what you set equal to 0. Then I have x minus 4 squared equals 0. And then x plus 2 equals 0. And we want to solve each one. Okay, so 2x equals 0. That means x equals 0, right? Divide by 2. Okay, for this one, all right, let's think about square rooting here. So x minus 4. The square root of 0 is 0, and 0 doesn't have a plus or minus, so I don't need to put that. And then add 4, so x equals 4. So even if there's an exponent outside, so this 2 here, I'm still really just looking on the inside since I have 0 on the other, on the right. I would have just said x equals 4. I can do that from here now. And then here, x equals negative 2. So there's 3 zeros, but 4 is actually used twice because of that exponent there. So I'm going to make a little chart. So I'm going to list out the roots and the multiplicity of each root. And then the action that does to a graph. So it either bounces, so it touches the 0 and goes back up, or it goes through. Okay? So I have 3 zeros, 3 roots, 0, 4, and negative 2. Okay, the multiplicity when x is 0, so I'm looking at their exponent. So the exponent on x here is 1, so the multiplicity is 1. The multiplicity when x is 4, so this 0 here, the multiplicity is 2. And then negative 2, what's the multiplicity? 1. Okay, that tells me then that the degree, the total degree, is 1 plus 2 plus 1, which is 4. So if I multiply that out, if I multiply my original function all the way out, I would get an x to the 4th. I have 4 zeros. 4 is used twice. And so there's 1, 2, 3, 4. Okay. So has an odd multiplicity, then it goes through. It goes through the graph. So I'm going to write that here. And don't get caught up with this. You're not going to have to memorize this just yet. That's not till later on. If it has an even multiplicity, then it has a bounce at the graph. So this one, 4 with a multiplicity of 2, there's a bounce. And then negative 2 with a multiplicity of 1 goes through. Okay? Alright, so I'm going to go ahead and graph that. I also, to graph this, have to know a little bit about my function and a little bit about the end behavior. Again, don't get caught up with this right now. For your quiz and stuff, you'll have the graphing calculator. Okay, you'll be able to look at it on your calculator. We will look at this in more detail later on. So because it's a 4th degree polynomial, I know that the end behavior is either both ends up or both ends down. That's because that's an even degree. Okay. Again, you don't have to have that memorized yet right now. And since it's positive a, so the number out front is positive, there's not a negative, that both ends are up. So that's going to help me when I go to graph this. So that means I'm going to end like this. Okay, so let me then graph my zeros, my roots. So that's at -2. I also have a root at 0 and a root at 4. Okay, so I'm starting up here, and I'm going to go through -2 first. I'm going to hit -2 first, and that action is that I go through. So I go through -2. And then I have to get back to 0, so I have to curve somewhere here. And I get to 0 next, and I also go through. Okay, then 4 is where I go last, and at 4 there's a bounce. So I go like, I bounce and go back up. And then I'm just going to put arrows here. Can erase these now. Okay, so I'm not looking for how far down this goes, okay, or where I turn here. Okay, I'm not necessarily, I can figure those out, and we're going to talk about how to do it on the calculator today. I'm not asking for those points right now, those minimums and maximums. I will later on, but we're going to do that with the calculator. Okay. All right, so what I want is I wanted this graph so I could find, so here is my function. Okay, let's look at the interval where y is less than 0. So let's use the graph to solve where y is less than 0. So when I'm solving these inequalities, remember, I'm looking for the places where y is less than 0, but I write my answer in terms of x. So looking at my graph, where y is less than 0, so my x-axis, that's the 0, that's where y is 0, and less than would be below. Well, I only have this part right here that's below. So we're writing this in terms of x. So again, I don't care how far down it is. I just care that it is less than 0 somewhere. It's less than, not less than or equal to. So I have those open circles there to show that I'm not including those. Open points. So I write that in terms of x. So that would be from -2, where x is -2, to where x is 0. 0, then I would have brackets. The brackets would mean the equal to. Okay? So this chart was just to help me get it graphed. You can use the calculator. We're going to be typing other stuff in today, so you should be somewhat comfortable with typing things in to see what the graph looks like. The only thing that I had marked there were my zeros. Okay. So we're going to talk about increasing and decreasing parts of functions. Don't get too caught up with this. This is just the definition of where it's increasing. It looks a little confusing, but let me just explain what it says. So this is what it's saying. Your function is increasing if it's going up from left to right. Okay, that's all we need to know. That if it's increasing, then it goes up, your graph goes up from left to right. Okay, this just means that, so this is bigger than this distance because it's going up. All right, I'm not going to ask you that definition or anything like that, so don't get too caught up there. The same thing with decreasing. It's decreasing if it goes down from left to right. So you read your graphs left to right. If it's going down, it's decreasing. Okay, and then it's constant. So constant is what we're going to look at as well. If from left to right, it's not changing. It's just a horizontal line. So if it's a horizontal line, then we say that f of x is constant. So let's look at a graph and we're going to talk about the intervals then. We're going to, again, write the intervals in terms of x. So this graph is an example of a piecewise function because you have different types of graphs all connected together. So different types of graph on the same graph. Okay, so just like when we were doing the inequalities, greater than or less than 0, your answers will be written like a domain, so in terms of x. So it's not the actual domain, they're just written like a domain. So we'll be writing intervals in terms of x. Let's point out just where it changes. So I start down here and there's an arrow, and I go to here. So what's it doing this first part? Increasing. So even though the arrow is pointing down, we read from left to right. From left to right, it's going up. So it's increasing here. Okay, and then here is where it stops increasing. So that's the point -2, 2. Okay. And then it goes here to here. So what's it doing there? What did it do next? Constant. It's a horizontal line. This is the point 1, 2. Okay. All right, then what's it doing next? It's increasing again. Okay. That's the point 3, 5. Okay, and then what's it doing here? It's decreasing. Thank you. Okay. I heard it. Just speak up. Okay. So with increasing, decreasing, constant, we use only parentheses. We don't use any brackets. We don't use any brackets because even though these are points and they are included in the graph, these turning points are not considered increasing or constant, okay? Because it can be both. So it goes up to here, and it's just a turning point. It's not increasing or constant. So we use only parentheses for all of these intervals, okay? Increasing, decreasing, constant, only parentheses. Now that's not the same as greater than or 0, less than 0. If it's greater than or equal to 0, less than or equal to 0, you can use brackets. But for increasing, decreasing, constant, only parentheses. Okay, so let's write those intervals. So I want my increasing intervals. So I write these in terms of x. So these two that I've labeled increasing here, I have two different increasing intervals. I have from negative infinity to where x is negative 2. So the x, we're doing x values. From negative infinity, because of this arrow, to negative 2. Since I have another interval, I have to use a union sign. Okay, so then that interval, where x coordinates here, 1 to 3. So with increasing, decreasing, constant, only parentheses, because these points are not constant or increasing or decreasing. They're just a turning point. Okay.
Why is there a union between the two of these?
Because there are two places that it's increasing. So it's asking us, where is it increasing? Well, it's increasing here and here. So if you were choosing a point, you would look here or here. So anytime you have to have more than one interval, you use a union sign. All right, I'm decreasing and just in one place. Okay, left to right, so from 3 to positive infinity. Okay, and then I'm constant from negative 2 to 1. Okay, yes?
Why is it not exclusive from greater than negative?
Because I'm using x values. Okay, so I start here, and then it's decreasing. The graph is going down as x gets bigger and bigger and bigger. So x is going to get bigger. Y, the graph will go down. Y will get smaller. Any other questions about that? Okay, we're going to look at another one. Yeah, so we're just looking at the x intervals where it's increasing, constant. So we, again, read it like y because it's up or down. That's how we're reading it. But we write our answer in terms of x. Okay, so I'm going to let you do this one, but I'm going to help you out. I'm going to write where these points are. This is also an arrow here and a point here. Okay, this is -4, 3, -1, -4. Two, 4, and 4, 1. Oh, and 5, 5. No, this one is a point. The left one is an arrow. Left one is an arrow, right one is a point. So I'll give you a minute if you want to try this one. Okay. So Jacob, where am I increasing?
From -infinity to -4.
Okay. So parentheses -infinity to -4. Okay. Union. Good. -1 to 2. Okay. Good. And remember, I can only use parentheses. So even though this point here is an endpoint, it is part of your graph, but it's no longer increasing at that point. So I'm increasing up to that point, but once I'm at that point, I've stopped increasing. Okay, so it is not included. So for all of these, only parentheses. Good. Okay, thank you. Olivia Wilson, where am I decreasing? Okay. Good. Everybody good there? Okay. Alyssa, where am I constant? Okay, good. So I'm just going to say A. Good. Any questions about that? Okay, let's practice now with the graphing calculator. Now, you probably could graph this without it, but let's just use the calculator so we can see. Yeah. Okay, so with your calculator, you want to go to y equals so top left is y equals. Make sure everything's cleared out. The plots should be turned off as well, so you should not have a black box anywhere. Okay, if there's a black box, the highlighting any of the plots, turn it off by going up and hitting enter. That will unselect it. All right, so let's type this in. So it was 3 minus x squared. So x is next to alpha. It doesn't work. It does not work. So x squared, you can either use the caret key in 2 or x squared here, the square button above log, whatever, either one. Okay, so you need to set your window first, and it's best to just start with a standard 10 by 10 graph. So if you go to zoom, and then number 6 is standard, zoom 6. And as long as you can see, then the turning point, you can see your minimum or maximum, then you're fine. If you need to adjust your window, you can either go to window and change the values of where you want to go, or you could go to zoom and zoom in or zoom out if you need to do that. Okay, so I'm going to go, if you just hit graph, it'll take you back to your graph. Okay, so can I see where that maximum is? Where is that maximum? 3. So I'm going to go ahead and just sketch that graph. So I'm going to put the maximum at 3. And sketch my graph. Okay, that's all I'm caring about for the points here. In our next section, so after this next quiz, in our next section, we'll want to be specific about our points, but for now, just a sketch. I just needed to know this so I could determine increasing, decreasing, or constant. Yes. 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 Okay, so I'm increasing. Where would I be increasing, Mason?
Negative infinity to, or 0.
Good. Negative infinity to 0, to where x is. Negative infinity to 0. Okay? So then, Dorian, where would I be decreasing?
From 0 to
Good. 0 to positive infinity. Good. And then again, I don't have any horizontal lines here. Yes. With increasing, decreasing, constant, we're never using brackets. Okay? But that's not the same as greater than or equal to 0 or less than or equal to 0. That's also not the same as our general domain and range. So we've done quite a bit with graphs so far in this section. We've done just the whole domain and range of the function, which remember that's our boundaries. That would be how we box in the whole graph. Okay? We did greater than 0, less than 0, greater than or equal to 0, less than or equal to 0. So we did intervals for that. And then we also now added increasing, decreasing, constant. So all 3 of those are different things where we use intervals. So you have to understand the difference of what it's asking you. So if you see an inequality, you're looking at your x-axis as your 0, and you're looking above or below. Increasing, decreasing, constant, you're looking where's the graph going up, where's the graph going down, where's the graph staying the same. Domain and range, you're looking for your boundaries. How would you box this in? So my domain, well, is going to be negative infinity to positive infinity for x. My range will be negative infinity up to 3. Okay, that's how I could box that in. Yes. Well, you can always do domain and range of the whole function, is what I'm saying. So these are not domains. It just said write them like a domain, like with interval notation, x is an element. Okay. So this is increasing and decreasing. These are not the domain of the function. They're written like a domain because we have x as an element and it's an interval. Okay. All right. We're also going to use the graphing calculator to talk about relative minimum and maximums. So we have different types of maximum and minimums. But really the ones we care about are the relative minimum and maximums. So I'm going to come back up to the graph, but I'm going to go ahead and let you write the definitions down. You're not going to be tested over these definitions. Again, the main one that we focus on are the relative maximums or minimums. So the definitions are the same for minimum and maximum. Just change the words maximums to minimums. Change the words largest to smallest. Okay, but then they're the same. So our global maximum is the maximum of the entire function. So the highest point of the entire function. Not every graph has a global maximum or minimum. So again, you can change all the maximums to minimums and all the words largest to smallest. And the definitions are the same for minimum maximum. Relative maximum or minimum is the largest value over a specific interval, or smallest, if it's a minimum. So that's what we look at, is the relative maximum or minimum. I can call the global maximum minimums relative maximum minimums, because maybe I'm still looking over a specific part. So don't get caught up in determining which is which. We'll probably, in general, just call them all relative max or minimums, but I wanted you to know that there is a difference. And then endpoint maximum or minimum can occur at an endpoint. So if I go back up to look at this graph, I'm just going to point out what our relative maximum and minimums are. So these 2 points right here are both relative maximums, okay, because they both occur at the top here. So this is a maximum for this interval. This is a maximum for this interval. And technically, 5, 7 could be called my global maximum, because that is the highest point of the whole function. But I can also call it just the relative maximum over this interval here. So we'll just call it relative maximum. Okay, then this is a relative minimum. It's the lowest point of this interval here. So this interval here. And I can tell that's the interval because that's where it turns. It turns. Relative maximum minimums are turning points, so your graph will change from increasing to decreasing or vice versa. This is not a global minimum because this graph goes to negative infinity. So this does not have a global minimum, just a relative minimum. Don't get caught up with that vocabulary. I'm not going to be testing you. Is this a relative minimum or a global minimum? I'm not going to be testing you on that, okay? There is a difference, so we were just pointing it out there. So what we're going to do is use the graphing calculator to help us find where those would occur. So I'm going to walk through the steps, and I'll walk through slow, so feel free to write steps down if you want. I also have this note here. This is from your book. If you don't get the steps all the way written down, or you're kind of confused on what we're doing, you can always look on page 217 of your book to help you. Okay, so first of all, I want to go to y equals, and I want to type in this function. So I'm going to graph it. I need a graphic to see if there is a minimum, maximum, and where that would be. So clear the one from before. Okay, and then it's 2x squared minus 7x minus 1. Is anyone having trouble typing those in? Typing the graph in? Okay. We have already hit Zoom 6. We've already created a standard graph. So you can just hit graph from now on. Once you do Zoom 6 once, you only need to do it once. You can do it every time, though. It's not going to hurt anything. So you can either hit Zoom 6 to graph or just graph. Okay. Can we see the minimum or maximum? Yes. What I want to figure out is exactly where that is. If I couldn't see it, so let's say it was outside this window, then you can go and either change your window, or I would say try zooming out to see if you can see it. So it needs to be in the window of your calculator. You need to be able to see where that point is. All right. So is this a minimum or maximum? Minimum. So first of all, I'm going to write that it's a relative minimum. Technically the global minimum, but we can just call them all relative. Okay. So to find where that is, we need the graph to calculate that. So you want to hit second trace, because that has the word calc above it. Second trace. And this is a minimum, so I would want number 3. If it was a maximum, you'd want number 4. So number 3. Okay, you have to tell the calculator where to look. So you have to bound, so you're telling it the interval to look. You have to bound this minimum point. So this is left bound. So I want to make sure this cursor is left of that point. And it is, so I'm just going to go ahead and hit enter because it's fine right there. Now I need to go to the right side of that minimum point. So use your arrows, put your cursor so it's to the right side. Okay. Just make sure it's to the right. It doesn't matter how far, but just make sure it is to the right of it. Hit enter. And then for guess, just hit enter again. Okay, so you gotta bound it on the left, bound it on the right, and then hit enter for guess. And then it gives it to you. Okay, so I'm gonna write so x is 1.75, y is negative 7.125. Okay, so 2, 3 decimal places is fine. Okay, let me show you about zooming out or in. So if you hit zoom and you want to zoom out, let's say, then it's going to ask you where do you want to zoom out. And so right now it's the cursor's right here. I can move that up or down, left or right, wherever I want. And then hit enter and then it'll zoom out from that point. Okay? Okay. Any questions about that? Okay, we're going to stop there because the next problem is pretty long. So we'll pick it back up tomorrow. Please put your calculators up.